Now consider a coin of question 1.20. It is electrically neutral and contains equal amounts of positive and negative charges. So in the previous video in this series of question 1.20, there we have calculated that in the given coin that was made up of aluminium, we have this much magnitude of charge, that is 34.8 kilocoulomb. Now suppose that these equal charges were concentrated in 2 point charges separated by, in first case he is saying that we have to just separate them by distance of 1 centimeter, that is almost half the diagonal of 1 paisa coin. And in another case these charges are to be separated by 100 meter, and in the third case these two charges are to be separated by a distance of 10⁶ meter, that is about the radius of the earth. And in each case we have to find the force on each such point charge in each of the 3 cases, and what we can conclude from these results. So according to the question, we have this charge plus q, and we have this charge minus q, and the separation between them is r. This plus q and minus q has a magnitude 34.8 kilocoulomb. Clear? Now in order to calculate the force between these two charges, we will use Coulomb's law. So the Coulomb law is F is equal to K Q whole square, because both the charges are equal, divided by the square of separation between them. So in first case, this is say F1, we have K, the value of K is 9 into 10⁹ Q, that is 34.8 into 10⁻³ whole square, divided by square of separation, that is 1 centimeter, means 10⁻⁻² raised to the power 2. So if we solve it, so F1, now that comes out to be equal to 108.99 into 10⁻17 divided by 10⁻⁻4, or simplifying it we can write that it is almost equal to 1.1 into 10⁻19 divided by 10⁻⁻4, and finally we will get 1.1 into 10⁻23 Newton. See the enormous amount of force here. This force is very much large. 10⁻23 Newton of force. Clear? Now in the second part of the question, now what he is wearing just the separation between these two charges. So earlier it was 1 centimeter, now it is 100 meter. So for the second case, the upper part will remain as it is, that is 1.1 into 10⁻19 divided by 10⁻² raised to the power 2, so it is 10⁻⁴, and here it was 10⁻⁻4, so the difference is of 8 overall. So this will give you 1.1 into 10⁻15 Newton. Clear? So obviously the force will decrease, but still the force is very large. Now in the third case, again the separation has been changed, so now it is very large, almost that of the radius of the earth. So this is 1.1 into 10⁻19 divided by 10⁻12, squaring 10⁻6, so finally we will get 1.1 into 10⁻7 Newton, still very large force. So basically what we can conclude from this result is that the force between these two charges is so large, very large, still large, that it is almost impossible to destroy the neutrality of the atom here in our consideration.